Hey, welcome to part 3 of the basic derivative rules. And so what we have up to this point is we've been working with our powers. So we've been taking expressions, rewriting them into the appropriate power for x to a power. We also looked at the derivative rules, the very basic ones. And so now let's put those things together to do the derivatives of these expressions that we have here. Okay, so for the first one I want to do is the expression or the function 3 over x squared. So before taking the derivative, what we want to do is do a rewrite. So in bringing up that x squared as rewrite as an x to the negative 2. So those same techniques we've already done before. Now that we have the x to a power, we're ready to do the derivative. And when we do the derivative, it's that nice straightforward two steps. Bring down the power. So we're bringing down the negative 2. We're going to multiply that to the 3. And then we're going to subtract 1 from the power. We started with a negative 2 power. Subtracting 1 will give us a negative 3 power. And so there's our derivative. And just do a quick little rewrite. Our negative 2 times 3 will give us a negative 6. And the negative 3 power just basically tells us to bring it down to the denominator. For the second one that we're looking at is we started with that fraction, the 3x plus 2x to the 6th over x squared. We did a rewrite of that, knowing that we can separate those two fractions. And so now we've got our expression in terms of the appropriate powers. Now we're ready to do the derivative. Recall the sum rule says that two terms separated by the subtraction or the addition, we do each one individually. So when we do that first 3x to the negative 1, when we do that derivative, I don't care about the 2x to the 4th, not even looking at it, just looking at the first term. And so we bring the negative 1 down in front as multiplication, subtracting 1 from the power, and that's where we get a negative 2. Now the second term, I'm just looking at the second term, the 2x to the 4th. I don't care that we've already done the 3x to the negative 1. Don't care what we got as a result. Just doing those two things. And so I'm bringing the 4 down in front as multiplication and then subtracting 1 from the power. And those clean up nicely, and we get our final answer by converting that x to the negative 2 into a nice little fraction here, and then multiplying the 4 and the 2. For this next one here, we have 3 fractions. Once again, the sum rule says that we've got expressions separated by subtraction or addition. We do them individually. We also do the rewrite of the powers. So we're playing with the negative 1, the negative 2, and the negative 6 powers. And we do them each one separately. So when we do the derivative, basically we're dealing with the negative 1 power. We're bringing it out in front as multiplication, subtracting 1 from the power. For the middle term, we're bringing the negative 2 down in front as multiplication, and we're subtracting 1 from the power, which will give us a negative 3 power. And for the third term, we've got negative 6 out in front as multiplication. We brought down that power, and then we subtracted 1 from the power to get a negative 7. And so we're just doing those two steps again, bring down the power as multiplication, and then subtracting 1 from the power, because that's the pattern. And basically we can do the mathematics, upper level mathematics, to show that's not only just a pattern, we can actually prove it, and that it actually works. And so we now clean this expression up, working the negative powers, making them back into fractions. And so there's our derivative for our for our expression here. And then we go on to our square roots. So 3 square root of x. First step before doing the derivative, just convert that square root into the appropriate power 1/2. And then when we do the derivative, we're bringing a 1/2 out in front as multiplication. And then we're subtracting 1 from the power. And so 1/2 minus 1 would give us a negative 1/2 power there. And so now just doing a rewrite on that, the 1/2 fraction, the 2's in the denominator, the 3's in the numerator, and because x is to the negative 1/2, the x is going to be in the denominator, and because it's a 1/2 power, it's a square root. So there's two things going on there with that power. The negative tells put it in the denominator of the fraction, and the 1/2 power says make it into the square root. And the next one we're looking at is the 3 times the 7th root of x. Once again, let's convert it into the appropriate fractional power of 1/7. And when we do the derivative, we're still doing the same two steps, that dance over and over again. And so we got the 1/7 in front. We're subtracting 1 from the 1/7, the old power, and we're going to get a new power of -6/7 is our new power. And so then kind of cleaning that up. Uh-oh, got a typo here. Yeah, I do. This 2 right here should be a 7, so I apologize for that. That 2 right there should be a 7th. And we're playing with x to the 6th and the 7th root of that over 3. So I apologize. This 2 should have been a 7. So I'm going to end right there, and we'll do a few more examples and finishing up this derivative practice.